Hi, for today's lesson, we are going to learn about orbital overlap. In this topic, we are going to describe the formation of sigma and pi bonds. At the end of this lesson, students should be able to draw and describe the formation of sigma and pi bonds from overlapping of orbitals, and then explain the formation of sigma and pi bonds in the molecules. The concept that we are going to discuss in this topic is valence bond theory. What is valence bond theory? The valence bond theory is an extension of the Lewis structures that considers the overlapping of orbitals to create bonds. The valence bond theory and the molecular orbital theory explains why and how electrons are shared between atoms or formation of covalent bond. The valence bond theory imagines atoms with its own orbitals and electrons overlap each other and forming covalent bonds. The valence bond theory is based on the following four postulates. The first postulate, a covalent bond is formed when the atomic orbital of one atom overlaps the atomic orbital of the other atom. The second postulate, overlapping orbital contain a pair of electrons with opposite spins. The third postulate, there is higher electron density on the shared pair electrons region between the bonded atoms. And the fourth postulate, the strength of the covalent bond is proportional to the area where the atomic orbital overlap. Let's take a look for the first postulates. A covalent bond is formed when the atomic orbital of one atom overlap the atomic orbital of the other atom. For example, the two s orbitals overlapping. The overlapping region between the two orbitals forming a covalent bond. We also can consider the overlapping between the s and p orbital and between two p orbitals. Overlapping orbitals contain a pair of electrons with opposite spins. For example, the formation of hydrogen molecule. The two s orbitals overlap between each other and form a covalent bond. In the overlapping regions, we have a presence of a pair of electrons with opposite spins. The third postulate, there is a higher electron density on the shared pair electrons region between the bonded atom. For example, the sharing of one unpaired electron between the hydrogen atom gives a higher electron density in the overlapping region. The fourth postulate, the strength of the covalent bond is proportional to the area where the atomic orbitals overlap. This example shows that a larger overlapping areas, the stronger the covalent bond. There are two types of bonds. First, the sigma bond, and the second is the pi bond. Sigma bond is a covalent bond produced by the end-to-end overlapping of atomic orbitals on neighboring atoms. There are three types of sigma bond. First, the overlapping between the s and s orbitals. Second, the overlapping of s and p orbitals. And the third, overlapping between p and p orbitals. This diagram shows how is the overlapping between the orbitals. Now, let's consider for a few examples on how the formation of a sigma bonds. The first example is to show the overlapping between the two s orbitals in the hydrogen molecules. At ground states, the hydrogen atom consists of one valence electrons in one s orbital. Both of the 1s orbitals overlap to each other and share the unpaired electron between the two atoms. The overlapping end-to-end of one s orbital and another 1s orbital of hydrogen atom forming a sigma bond. Now, let's consider the overlapping between s and p orbitals in hydrogen fluoride molecule. At ground state, hydrogen atom has 1 valence electron, while the fluorine with 7 valence electrons. From the valence electronic configuration of the atoms, it shows both of the atom has 1 unpaired electron in their valence atomic orbitals. The valence atomic orbitals are overlapped end to end to form a sigma bond. Next, the overlapping between two p orbitals. Let's consider fluorine molecule as an example. At ground state, the fluorine atom have 7 valence electrons. From the valence electronic configuration, it shows the fluorine atom has 1 unpaired electrons. The valence atomic orbitals of the unpaired electrons will overlap end to end to form a sigma bond. How the formation of the pi bond? The pi bond is a covalent bond produced when two loops of p orbital of one atom overlap side to side on the neighboring atom. It occurs in a molecule with a double or triple bonds. Now, let's consider the formation of pi bond in the oxygen molecule. From the Lewis structure of the oxygen molecules, it shows that the molecules consist of 1 sigma bond and 1 pi bond. At ground state, oxygen atom consists of 6 valence electrons. From the valence electronic configuration, it shows both of the atoms have 2 unpaired electrons. One of the unpaired electron will give overlapping end-to-end between the two p orbitals in forming the sigma bond. Another one unpaired electrons will give overlapping side to side between the two p orbitals in forming the pi bond. Now, you can try to answer these questions. Draw the orbital overlapping and label the sigma and pi bonds of the following molecules. You can check your answer in the tutorial video. That's the end of our lesson today. We'll see you in the next video. Bye!